Okay, so now that we have mastered how to set up this problem, we're going to look at how do you evaluate the integral. And I always recommend you always do your algebra and clean up the integral first, then towards the very end apply our calculus. So here's our setup that I copied. So if you notice the highlighted version, the 1/2 they both share in common, so we can always factor out a 1/2, which drops down to this step right here. And I can also simplify with this 2 with this 1/2. And -6, the quantity getting squared, is 36 cosine squared theta d theta plus the green version, which is 2 pi thirds to pi. If you expand this using this expansion, it's basically 4 minus 8 cos theta plus 4 cos squared theta. Once again, this 36 is just a constant, so it's easier for us to pull it outside. So there's that 36 coming out. Cosine squared d theta plus 4 and minus 8 cos theta plus 4 cos squared theta. Now if you notice, we know how to take the integral of 4, we know how to take the integral of 8 cos theta, and those are all easy. But the only problem that arises now is as follows. We don't know how to take the integral of cosine squared and this cosine squared. So let's do some trick to it. So what the trick is, what we learned on section 8.3, whenever you have cosine squared, we happen to use our half angle. So how our half angle looks like 1 plus cos 2 theta divided by 2, and 36 is just a constant, so we leave it outside. And this all remains same. 4 minus 8 cos theta plus 4 is that constant, and again half angle applies here. Now if you look at this problem, this 2 once again is just a constant. So if we really want to clean things up and make things easier, we can always pull this 2 outside, which will multiply with this 36. So 36 times 1/2, or 36 divided by 2, will really give us 18. Integral from pi halves to 2 pi thirds of 1 plus cos 2 theta d theta. The next version would be plus, here is our other integral, 2 pi thirds to pi 4 minus 8 cos theta plus 4, simplifying with these 2 would be just a 2, and if I distribute this 2, that would become 2 plus 2 cos 2 theta d theta. Now please do not add these like terms, because they are not like terms, because this region right here, the integral bounds are from pi halves to 2 pi thirds. This region is from 2 pi thirds to pi. Now if that's easier, remember this was your R1 and this was your R2. Do them separately and then put them together. So if you think about the first integral, 8 is just a constant, first part. Integral of 1 with respect to theta is just a theta, plus the integral of cosine 2 theta is just sine of 2 theta. But do not forget our u substitution, and due to u substitution, if you take your u as 2 theta, your du, actually let me write it out, your du would be 2 d theta, so we need to put a 2 in here. To compensate for that 2, we need to put a 1/2, so here's that 1/2. That's my blue chunk, evaluated from pi halves to 2 pi thirds, plus the integral of 4 with respect to theta, in other words the constant with respect to theta is 4 theta, minus 8, the integral of cosine happens to be sine of theta, plus, if you look at this 2 is just a constant, so let's go ahead and add this 2. 4 plus 2 is 6, so I can really write this as 6 theta, and over here there's your 2, the integral of cosine 2 theta is just sine of 2 theta, but once again our u is 2 theta, so your du is 2 d theta, so you need a 2 provided you put a 1/2 in here. And all of these greens are evaluated from 2 pi thirds 2 pi. Our next step, we're going to try to evaluate the blue ones and the green ones separately. So the first part would be 18 according to the fundamental theorem of calculus, upper bounds minus lower bound. So you'd have 2 pi thirds plus 1/2 sine of 2 times 2 pi thirds is 4 pi thirds. Remember, we're multiplying with these two with the argument here for the sine, minus, when we plug in our lower bound, make sure you embed it inside a parentheses, so you'd have pi halves plus 1/2 sine of 2 times pi halves, which is eventually the 2's, you can get rid of them, so it's basically sine of pi. I'm done with all of the blue ones. Let's continue on the second part. Plus, let's evaluate the green ones. 6 times upper bound is pi minus 8 times sine of pi plus these 2's, we can just simplify them. So we are left out with sine of 2 pi minus, make sure you embed it inside a parentheses, 6 times 2 pi thirds minus 8 times sine of 2 pi thirds plus sine of 2 times 2 pi thirds, which is 4 pi thirds. Okay, now let's go ahead and evaluate them, but before we evaluate it, let's simplify. So from our unit circle, we know sine of 4 pi thirds is negative root 3 over 2. The 2's are gone, so you're basically leaving with sine of pi, which is 0, sine of pi, which is 0, sine of 2 pi, which is 0. 3 goes on to 6 twice. Sine of 2 pi thirds is root 3 over 2. And sine of 4 pi thirds is negative root 3 all over 2. Now if we clean it up, 18 outside multiplying with 2 pi thirds, positive times a negative is a negative root 3 over 4. If I distribute this negative, so I have negative pi over 2, and all of this is 0, plus, let's do the green portion, I have 6 pi, this is 0, this is 0. If I distribute the negative, it becomes 2 times 2 is 4, so I would have negative 4 pi. I'm distributing over, and if I distribute this negative here, I would have a positive 8 root 3 over 2. We will simplify it on the next step, as you can see already. This negative with this negative is a positive, and you would have root 3 over 2. Now if you notice, there happens to be like terms, which is 2 pi thirds and pi halves. So let's go ahead and do it on the side, so y'all follow. 2 pi thirds and minus pi halves. Our LCD here is 6, so I need to times it by imaginary 1, which would be 2 over 2 here, and over here it would be a 3 over 3, which will give me 4 pi minus 3 pi all over 6, which is just a pi sixth. So you would have 18 times pi sixth minus root 3 over 4 plus, these are my like terms here, 6 pi minus 4 pi, which is 2 pi. And if you notice, these are my like terms here, root 3. Luckily we have the same denominator, so we can just go ahead and write them as plus 9 root 3 all over 2. Also, if I happen to distribute it, this 18 with pi 6 goes on to 18 3 times, so it would have 3 pi minus 18 times 1/4 times root 3. 18 divided by 4 is 9/2 root 3 plus 2 pi plus 9 root 3 all over 2. Now if you think about it, remember we split them up into two parts, two regions. This blue region right here, and all of the green regions is the bottom, which is right here. And if you wanted to do the integrals separately, the blue regions R1's answer is this 3 pi minus 9/2 root 3, and the green ones is 2 pi plus 9 root 3 over 2. But please do not forget, if you happen to do them separately, to put them together and look at if there is like terms or not. Well, looks like these guys are in like terms, so your final answer is 3 pi plus 2 pi, which is 5 pi units squared. That's the area of this whole region. So the technique was finding the first upper half, times it by 2 using symmetry, but in order to do the first upper half, we split the integral into two pieces, and then we found the bound separately, which deals with two different functions. Thank you for watching. Hopefully this helps. Now I also want you to practice some more problems. So on the next video, I will talk about probably these problems.